Today we are discussing section 9.1, translating figures and vectors. Our goal is to use mapping rules and vectors to translate a figure. Our first two terms are preimage and image. A preimage is before transformation, and our image is after transformation. When talking about using transformations, we use what's called prime notation. So for example, this piece here is read A prime, and it is the image of point A. So for example, we have point A, we transform it, we have A prime. We transform it again, we have A double prime, and so on and so forth as it continues. We add another prime for each transformation. Our first transformation we are going to discuss is a translation, also called a slide. A translation moves or slides a figure in a plane. And when we say it moves, it can be left, right, up, down, or any combination thereof. So for example, I have this star. If I take this star and pull it, now I have translated it. And we mark the translation with that line. And this would be to the right and down. When talking about translations or writing translations, we use what's called a mapping rule. XY is your preimage. And then you have some rule where you have X plus A, so A is the amount of horizontal movement, and Y plus B, so B is your up and down. Again, positive will go up, negative will go down. Same with A, positive will go right, negative will go left. In this example, KLMN is a quad with vertices. K is 0, negative 2, L is 4, 3, M is 5, 2, and N is 6, negative 1. So find the image after the translation. First thing you need to do is you need to plot KLMN. And once we've done that, we will connect. Now, there are two different ways to go about figuring out these points. You can do it algebraically, so you can start with K as the point, 0, negative 2, and that maps onto, and then use your mapping rule. So 0 minus 4, and then negative 2 plus 2. So that means K prime is negative 4, 0. And then plot 2, 4, and plot K prime. The other way to do this is to say we recognize that X minus 4 is 4 left, and Y plus 2 is up 2. So we are going to go from K, we're going to go 4 left and up 2. You can use either method when doing these. If you want to do it algebraically, do it for all 4 points and then plot them. If you're just going to slide the points, which is typically what I would do, 1, 2, 3, 4, do that as well. And once you've labeled your K prime, L prime, M prime, draw your new image. There's your translated figure. An isometry, all that means is a congruent transformation. A translation is an isometry. You will get a congruent figure. When writing a mapping rule, we always go from image to, from the pre-image to the image. So here we start with E and go to E prime. Could you pick D and D prime, F and F prime? By all means. So we start with writing, we have X, Y, maps onto X, Y, and now we need to fill in. How far do we move X? Well, we are going to count. We go over 1, 2, 3, 4, 5. And we're going to the right, so we're going X plus 5. For Y, we are going up 1, 2, 3. So our Y is plus 3. Now, to verify that the translation is an isometry, this is another way of asking to show that they are congruent. Now, we are working with a triangle in this example, so we need to show either side, 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 angle, angle, hypotenuse, leg, or any of those. Now, when we have triangles like this in a coordinate plane, most times you're going to be doing side, side, side. So what we will do is verify that EF is congruent to E prime F prime. And to do this, we're going to find the length of each. Now what's great about these is on the coordinate plane, we now have a right triangle. A is our horizontal piece, which in this case is 1. So we're going to have 1 squared plus our vertical piece, which is 2. So we're going to have 1 squared plus 2 squared. And take the square root of that, and that equals EF, just using the Pythagorean theorem. And so we get 1 plus 4. So EF equals the square root of 5. We're going to do the same thing with E prime F prime. And we find that it is also square root 5. Since these are both square root 5, they are congruent. You would go ahead and do the same thing with ED and E prime D prime, as well as FD and F prime D prime. Vectors. Vectors are another way of naming or describing a translation. The big thing with a vector, you start here what's called the initial point. And your vector goes to your ending point, in this case, G. When naming it, same thing, you start at the initial point, you go to the end point, and we notice that the notation is a one-tailed arrow. So it looks like a ray notation, except the tail only goes on one side, typically the top. And we recall our mapping rule told us xy mapped onto x plus a, y plus b. When using component form, otherwise called vector form, we just have the change. So what is A, the change in the horizontal, and B, what is the change in the vertical? Notice you need to use the pointed brackets here. They look like the less than and greater than symbols. If you don't use the pointed brackets and they're rounded, they are parentheses, and you're talking about a coordinate point and not a vector. In this example, we are asked to name the vector and write its component form. So we'll start down here with the purple one. Our beginning point is point A, and our ending is B. So we have the notation part. Again, we're going to have our pointed brackets, and we look at the horizontal change. So we go over 1, 2, 3, 4, 5, 6. And we go down 1, 2, 3, 4, and since it's down, we do -4. try writing the vector form for the orange and the green vectors. As we see, CD is 4, 4, and EF is 0, 5. The point negative 2, 3 is translated to 3, negative 2. So our starting point will be A, our ending point A prime. Write the translation vector in component form. So our first part is, how far is it from negative 2 to 3? You can think about this on a number line if you want, in a coordinate plane, or you can simply take 3 minus negative 2, and we get 5. Again, remember when doing this, it will be image minus pre-image. And for the y, we are going to take negative 2 minus 3. Again, image, so A prime, minus pre-image, and we get negative 5. So we are going right 5 and down 5. You and some friends are going snowshoeing. Write the vector or component form of the vector form of the cabin. Oh, sorry, the vector form from the cabin to the ski lodge. So we have from the cabin to the ski lodge, that vector. We are going from the coordinate 0, 0 to 1, 2. This one is fairly easy, in that you're going from 0, 0 to another coordinate point. It says write the component form of the vector from the hotel to the cabin. So here we are at 4, 2, and we are going back to the cabin. So we're going from 4, 2 to 0, 0. So from 4 to 0 would be negative 4. And from 2 down to 0 would be negative 2. When doing these, you need to read carefully to make sure you are going in the right direction. And lastly, to find the length of the vector, we've done this, we've seen this before. It is simply the square root of a squared plus b squared.